All right, by my watch, it's time to start, and I just lost one person already, so we're going to get going. Hi, I'm so excited to be here at our second day of Cephalicon. My name is Greg, and we're going to talk about testing Ceph. Going to go over some of the history of the Ceph testing frameworks and look at what developments we're working on and what opportunities there are for other people like you to contribute to the testing the Ceph project. So in Ceph, I'm sorry, I killed my Who Am I slide. So I'm Greg. I've been working on Ceph since June 1st, 2009 or thereabouts. So I'm just coming up on 10 years, which is really exciting and very strange for me. I currently am working on the RADOS team and focused on and doing some shepherding of testing efforts throughout the project. In the past, I've worked all over the place. It's been a long time since I did anything in RGW or RBD, but back long ago I have. I was the Ceph tech lead for several years up until, I think, 2015. Although I don't remember exactly. And I'm really excited to be here. So the biggest Ceph testing system we have is called teuthology. It's the academic study of cephalopods, and the guy who named it thought it was fun. And the early design of teuthology started about 8 years ago, I think. We needed to formalize Ceph testing. It was really important because we were running a lot of Linux FS tests on our local development boxes and seeing if we passed. But I remember at least one time there was this bug that we found, and I don't remember exactly what it was, but something went wrong, and we traced through the source code to figure out why, and we found an if statement, and we said, oh, that if statement is obviously backwards, so we swapped it, and the bug went away. And then and it was fixed. But then a few weeks later, a different person ran a different test, and they traced it through the code, and they came to an if statement, and they said, oh, this if statement is obviously backwards, and they flipped it back. And it turned out 3 weeks later that I ran the original test again and said, oh, it's not working, and we had swapped the same if statement back and forth 3 or 4 times over the last 2 years, depending on which test had been run most recently, because it wasn't a complicated enough condition, and we didn't realize it, and we didn't have any sort of regularly running test frameworks telling us that something had broken, so regressions were really easy to introduce into the system. We were not real sophisticated at the time. We had some people involved in the project who tried to build up good systems. There wasn't really anything available for testing distributed systems at the time, at least not that was accessible to us on our budget as an open source project. We tried using Autotest, which is involved in the Linux kernel a lot because a lot of our early people were familiar with those processes, but it didn't work very well for something in the nature of Ceph. In particular, it's really important that we be able to manipulate multiple machines at once. We're a distributed system. We need to make sure that if an OSD crashes or we kill it really, really crudely, that the monitors and the other OSDs and the clients keep on functioning correctly. So, a guy named TV, who was much better at these sorts of things than I am, came up with a plan. He wrote this thing called the Orchestra module in Python. It's basically just wrapping SSH up in a lot of pretty things, and allows you to have a central test runner and SSH out to those nodes and run tests against them. Teuthology itself started as a test runner. It wasn't a big framework, like it is now, and which we'll get into. It was initially just a test runner. You would write tasks, which were sorts of little pieces of code to do things like, oh, install the packages I want, turn on a Ceph cluster, run this file system test, and it would run those tasks on targets, like machines, just physical servers somewhere, given a mapping of roles, such as, okay, like a machine 1 is an OSD and a monitor, and machine 2 is another OSD and a monitor, and an MDS, and machine 3 is just another monitor. And it would automatically, set everything up. It would watch the Ceph health and make sure that things continued operating the way we expected. It would run the tests. It would copy the results of all the remote nodes logging back into the folder where you were running it from on your development box, and clean up the system. This was an old example of the actual targets we were using, of a roles mapping, and of some of the first tasks that he actually wrote. The Ceph one, I think at the time, did the install as well as turning on a cluster. K-client would run a kernel client on a kernel client on all of the named clients in that, all of the roles named in that list, And then work unit was a name we have for just shell scripts that run tests. And this one, and so we have a task that runs the shell scripts on whatever we name. Tasks in teuthology can actually be context managers. So they're not just a one-off thing. The Ceph task turns on a Ceph cluster and then yields to the next task in the system until it comes back. And then when you come back to the Ceph task, it cleans up. This is convenient for doing things like turning on an OSD Thrasher that runs in the background while you're running other tests that may have no awareness of it. The teuthology test runner lets you combine YAML fragments, because YAML is how we define all of these things, as you've seen in these examples. And so you can just run the teuthology command line and give it a targets.yaml, which may change whenever your available machines change, and then a mapping of the roles, and then the actual test you want to run, or any other combination. It just glues them together and throws the archive in the folder you've given it. In this case, something like this is much shorter and simpler than our jobs tend to be now, but covers the essence of them. And the logging is really useful, in addition to the original starting config.yaml. Wow, yeah, okay. In addition to the original configuration of the system, it has all of the Ceph daemon logs that are produced on all of the remote nodes. It brings them back so you can trace through and find out what the cause of crashes and things that you might have induced. A summary.yaml file saying whether it passed or failed, and if it failed, what the cause of the failure was. And the teuthology.log is the actual test runner itself. Today, teuthology looks a little bit different. First of all, instead of having 4 developers in an office using a few shared machines and just saying, hey, I'm using these 3 machines, don't touch them, we have a gigantic lab. We call it the Sepia lab. That's a kind of octopus, I think. And it's devoted to Ceph development. We have 250 plus servers in it. I think these numbers are a little out of date now. It's devoted to running Ceph tests 24/7. We keep it busy pretty much all the time, except for over very long breaks like Christmas occasionally. And SSH access is granted to people who are engaged in the development community and have a demonstrated commitment to building Ceph. It's more than 100 people. It's, I think, not more than 200 yet, but that sort of order of things. Teuthology has a system for letting you lock the servers, because we have 300 servers, we have 100 people who are trying to run tests. We don't want to collide with each other, so you can run a teuthology lock command and get a certain number of servers, and then go off and do what you want with them. More often, though, instead of locking servers and running a test, we say, hey, I would like to schedule a job to run this test and then give me an email back later or something. So teuthology-schedule, we have a beanstalkd running. This is these days grossly insufficient, but it was the first thing we built and it still hasn't been replaced. And you just put jobs into beanstalk with a priority, and it pulls them off sequentially in priority order. We have 50 teuthology worker processes running on a central node that just grab those jobs off and invoke teuthology with the fragments that are specified. Teuthology runs on QA suites now instead of individual jobs. These suites are directories of fragments that can combine to form complete jobs, which I realize is a little abstract. So, for instance, this is a prune example of the RADOS verify suite. So we have a couple of different things, different subfolders within here. On all of them, we have a Ceph and RADOS.yaml that do some config setup. We have options for clusters, where all the jobs it runs on run against 2 nodes, and we have this extra openstack.yaml file in case you're running against an OpenStack cluster. We have two options. You can either run with the default thrashing or with no thrashing. A thrashing is a sort of chaos monkey we'll look at later. And then we have a few different object store backends. I think this has also changed actually since I put the slide together, because we're pretty focused on Blue Store now, more than we were in the past. But we got a couple different Blue Store options in File Store, and 3 different particular tests we want to run in the task directory. And so if you run a suite, then we have a teuthology suite command that you'll point it at this directory and say, hey, run this suite for me, and it will generate jobs by combining them. So this first one will be all the highlighted ones. and then it'll step through changing each YAML within the directories until you have the full combinatorial expansion of the system, which is really useful for making sure that we have the full coverage because, we've added this new feature and we want to run tests against it, and we don't want to fully specify all the possible combinations ourselves. We just want to say, hey, now that I've added, some new kind of caching, I want to run all of our tests with the caching on and all our tests with the caching off. There are a whole bunch of suites that provide test coverage. There's a list of them, whatever. What's important is that this is very comprehensive. It covers all of the core Ceph functionality and a lot of the extra stuff. And these suites include Thrashers. These are chaos monkeys that we run while other tests are in progress. In particular, we have a whole lot of OSD thrashers and some monitor thrashing ones, and we run all of our core RADOS tests with thrashing enabled to make sure that we maintain our API guarantees under all kinds of very ridiculous failure conditions. So that's sort of the use of teuthology from a single user, a little bit at a time perspective. Within the community, we use teuthology for our Ceph testing. What that means is that committed developers give access to the Sepia lab and use it to run tests against their in-development branches when they're building new features and they want to make sure they work. And you can do that by pushing a branch to a cephci.git repo within the Ceph group on GitHub. And those automatically get built by a different system that I'm not going to talk about here, but which I believe Ken and Alfredo will probably mention briefly in their talk on building Ceph. And then once that's built, you can schedule a suite against your branch, and it'll run, and the results are publicly available on a website called pulpito.ceph.com. You can set it up to email you personally, and you can go and look and see, oh, hey, I broke something. Let me go look at the logs that have been saved on the teuthology server, or access them through the web and figure out why. In addition, we test Ceph pull requests. We accept pull requests from any random person who comes in, and once the tech leads or other reviewers look at them and say, okay, I think this might work, it looks okay, so I'd like to run it through an integration test and make sure that that passes before we merge it into the master build. And there are some tools to help do that that various developers have built, one called ptltool.py. And these allow us to do things like we have tags on GitHub that can say, hey, this needs to run through QA, and others that say like, hey, I'm including this in my integration branch. And tools will help you, will go and find, okay, all the PRs that are labeled for this integration branch, merge them into a single branch, push them to cephci.git, then schedule a run. And once that's done, say, okay, this run looks good, so I'm going to go back and approve all of the PRs included in it for merging or not. It's important that nothing merges into the Ceph master without passing these tests, or the subset that leads believe are appropriate, because otherwise it's just too huge and complicated a system. If we merge stuff without passing tests, it would break. And on the very, very rare occasions when we do merge something without tests, because it's very urgent and we know that it's a simple and correct fix, we're right about half the time. Usually when that happens, it is immediately obvious because a build fails rather than because we broke an algorithm, which is reassuring, but still, every time that happens, we're like, okay, no, really, nothing can merge without going through the tests, or we screwed up really badly. And finally, we have nightly jobs that are scheduled automatically via a cron tab. The source file for it is posted on GitHub. We run all of the suites generally from 1 to 7 times weekly against master and our stable branches just to make sure things are staying kosher. Those results are also publicly available all the time, and the leads tend to go through them and make sure that everything looks the way we expect, and that we aren't missing new issues that haven't been reported by users that are coming into the integration testing system. And this is good for catching things that might only happen one time out of 5 or one time out of 10, because everything runs through an integration branch. But if it's a rare race condition, it might not turn up in that one branch, but does turn up later if we missed it in the code review itself. Now, there are other systems for testing Ceph that are very important and cover different kinds of things. In particular, we have a lot of Jenkins-based tests. that are used for testing the Ceph Ansible and Ceph volume associated pieces of the overall ecosystem. These are nice because they're really easy to integrate. They're much easier right now to integrate with GitHub. So if you like put in a PR to Ansible or to Ceph volume, then they can just get tagged, and then the tests run, and they give you a pass or a fail report. That's not really suitable for the full Ceph suite because the RADOS suite requires a reasonable run of that requires a couple thousand machine hours. So we're not going to do that on every PR automatically, but. In addition, we have a make check target in the repository, and Jenkins triggers that on every push, or at least every approved push, to make sure that we haven't broken something really, really obvious. A big important part of that is what we call the Ceph object corpus. Ceph is a data storage system, and it's really important that when you upgrade your Ceph storage, it still be able to read all of the data that it wrote in the last version. And so we have a system that lets us run a teuthology job, or that lets us run a teuthology suite and collect samples of all of the encoded pieces of data and save them into the Ceph object corpus, and then we make sure that, and we do that on our major releases, and then we make sure on the next major release that it can still decode all the data written by the previous ones that we support upgrading from, and that when we encode something, we get the same thing back when we decode it. But collecting all that data for the Ceph object corpus is actually pretty time intensive and very manual. And so Kifu recently did it but it was the first time in a couple of releases, and we've actually missed some. So if you're interested in contributing to Ceph, this is not a real big coding job, but it will get you into the depths of the testing system if you would like to learn how to maintain the Ceph object corpus and improve our ability to gather that data and validate it on every push. But with all that said, there are some test gaps in the system, or in the way we test Ceph right now. I want to cover my butt a bit here because, and I don't want you to think that we're bad at it. We're actually very good at testing Ceph. The functional coverage is great. Most issues that get picked up by users are of the kind of thing you really can't expect a testing system to find. And the functional coverage of Ceph is very good. We have specific tools that validate the behavior of the APIs, and we run them against the Thrashers to make sure, like there are a lot of systems that claim to do distributed storage where they work one way when the system's healthy and a completely different way that isn't documented when the system's broken, and you just have no idea. And we're very careful to make sure that's not the case, doesn't happen with Ceph. We make sure that we can inject failures to test the daemon recovery all the time. So that we can do things like say, hey, what happens if the network just starts randomly dropping one message out of every 10? Are we going to notice that and behave appropriately? We do things like fiddle with the raw objects inside of files, or with the raw objects in RADOS, and test that Cephs notices that with its scrubbing mechanisms, and that it behaves appropriately and exposes that to the user correctly when it thinks that something is broken, and that the recovery works. We fiddle with the raw disk state on BlueStore or FileStore, and test that the OSD notices that at the appropriate touch points on any read in BlueStore or when scrubbing and stuff happens in FileStore, and that the RADOS recovery works. So there's a lot of things we're very careful about. But there are some parts that don't get covered. Teuthology handles daemons directly by SSHing into the node, and then it runs Ceph OSD in a foreground SSH process. So it does not test our unit tests, or our units for integrating with systemd or other init systems. It does not test the integration with Kubernetes at all right now. Teuthology does not do performance testing. We have a new perf suite as of late last year that uses the Ceph benchmark tool from Mark Nelson, and that's been used by the performance and hardware testing communities around Ceph. But the number of tests it actually runs is very limited, and there isn't any analysis of it built into any system right now. Scale testing is not really suitable within Teuthology because we expect tests to run within an hour or two, and for them to be very small so that we can run lots of tests. But Ceph, of course, is a scalable distributed system, so we want to be able to make sure that we scale up to tens of thousands of nodes. And so that's a test gap we have right now. And in addition to the init system itself, Teuthology handles all the Ceph installs, the package installs, the setting up the cluster configuration, injecting it into the Ceph cluster or the ceph.conf. And so it doesn't test our deployment tools like Ceph Ansible or Ceph Deploy or DeepC. But we have some potential fixes that we'd like to look at. And if you want to get involved with any of these proposed solutions, we've been talking about them some on the mailing lists, and we would love to have more people working on them. To fix teuthology handling daemons directly, we need to expand the internal teuthology and Ceph QA suite APIs to restart and signal using the init system instead of actually, this is an actual piece of code out of teuthology where we have where we've abstracted out the monitor remote node, but we can just call this run command, and we issue a kill all -9. For performance testing, we've started gathering the historical data on performance, and we want and then we can guess a rough outer limit and fail test when it exceeds some difference. But I don't think this has actually been done yet, and we started gathering data 8 months ago, so we clearly need to figure out do that and come up with a better long-term solution, some kind of I don't know how it would work really, but some kind of analysis system that tracks the performance and alerts when they're out of bounds based off of the machines you're running on, because the machines might impact their performance, and the different versions will obviously perform differently, hopefully faster as time goes on rather than slower. But we don't want to then be like, oh, you ran Firefly for the first time in a year and everything's slow, so fail. In terms of scale testing, we've just decided teuthology is an integration test framework, and it's not a good place for long-running tests like this. So various downstreams have done some things, but we in the upstream would also like to figure out how to inject aged and large-scale data within short-running tests by doing things like running a long-running RADOS gateway job and then collecting the OMAP inputs and the file data, and then just figuring out how to stream that into RADOS much more quickly than by going through RADOS GW itself. And we'd also like to be able to get tests that run with longer-term allocations, either in a smaller but still reasonably sized portion of the community lab, or in somewhere that's been donated by some community member with resources. And to fix and to get test coverage of the install and cluster config, we'd like to again write new internal APIs so that we can request installs and farm them out to Ceph Ansible or DeepC or Rook or whatever else, and so that the Ceph, the functional tests themselves, don't care who installed it. They just know that they just know that there was a thing that ran the install, and the install set up the internal interfaces and Python objects for them to go poke at in the way they expect. There's one other problem I haven't mentioned so far. The new Ceph Manager orchestrators that we've talked about a few times and that Sebastian has been discussing are not integrated into the testing at all right now. And that's because they rely on Ceph Ansible or DeepC or Rook to do things, and except for the one that runs on SSH, but that hasn't been integrated yet. And since we aren't using those at all, there's no way to test the orchestrators within the teuthology system, and that's a pretty big hole. So right now, Sebastian is working on orchestrator tests that, instead of being within teuthology, will eventually run inside of Jenkins, just using the Tox framework with Terraform. And that'll get us some coverage, but not sort of the integrated thrashing coverage of things, which is better, but still a little sad. We'd really like to integrate these deployment tools into the teuthology framework once we have the other internal APIs we need. And so hopefully that happens in the near future, but we'll see. It's something that I've been hoping will happen and have been trying to do a little bit of work on for a while without a great deal of noticeable progress. And this particular problem is a key example of how not having an integrated testing framework can have negative long-term consequences. And it's something that I'm worried about as we spill. In addition to the test gap coverage, there are some framework weaknesses within teuthology, which you might have heard a little bit about if you went to, oh no, I'm going to forget his name until I see it on slide. If you went to the DigitalOcean talk about running teuthology yesterday. So teuthology is strongly tied to the Sepia community lab. It's supposed to go anywhere, but we have a lot of hard-coded value sneak in because we don't have any way of preventing them from appearing. The documentation is often unclear. There are a lot of services you need to set up in order to make everything work. So other groups running teuthology, which we first started hearing about a year ago at the China Cephalicon, mostly do a local port. They run through and they find all the places where we talk about ceph.com for packages, and they replace it with their own package URL and their own URLs for things like Pulpedo and for the repositories and everything else. And this makes developing tests difficult. The code and test debug cycle involves locking the lab machines, doing machine images and package installs. You need built Ceph packages in order to actually run any tests, so you have to wait for some external package repository system to finish. And it makes it hard for third parties to contribute to teuthology development in general, in addition to people just testing Ceph themselves. There are some things that would have been nice if we'd done in order to prevent this, like doing regular teardown and setup as part of our practice. It would have been good once we found out that people were trying and failing to work more closely with them to understand what problems they had and resolve them. We just never thought about how people who didn't have access to the lab would run Ceph testing, and that's unfortunate. There was one previous solution to this problem called teuthology OpenStack. One of our previous contributors, it was just some scripts that would let you turn on a whole teuthology system in an OpenStack cloud and run through a specified suite and get the results back. And that was useful as long as you could afford to run an OpenStack cloud or to do that within an OpenStack cloud. But it was built on CLI commands that have changed and are deprecated, and so it doesn't work real well at this exact moment. There is a more modern solution called the vstart runner, which provides you a restricted API within the teuthology framework that lets you run some tests out of a local Ceph source tree build. We just have a script called vstart that turns on a specified number of OSDs and monitors and things on your local dev box. And so you can run a lot of the file system tests and some of the RGW ones just against that. We have started doing more deliberate work to foster a community around testing Ceph. I run a weekly meeting on Wednesday mornings US time to discuss, and you can get details about it on the website. We have started reaching out to some of the known users and doing active work to merge their enhancements and their local ports into the upstream in ways that make it easier to work with. In the future, we want to keep looking at the localization patches and replace them with configuration options to make that setup easier, and to rebuild teuthology OpenStack with more reliable APIs. There are some successes coming out of that already. SUSE has had their own fork of teuthology from the upstream community lab and from what Red Hat use, and they've almost finished bringing their fork back into the upstream so that they can run out of that. So thanks to Kier. And I now know that DigitalOcean deploys teuthology in their cloud, and you can do that too if you want, just in their cloud without any fork at all, but just some mangling of the infrastructure. All right. So another problem, teuthology doesn't have good trend analysis tools. We can really easily tell that a test has failed. It shows up red in Pulpedo. There's a summary.yaml that says failed. We get core dumps and we have robust mechanisms for triggering that failure. If there's a core dump that isn't whitelisted, then we fail. If there's a warn or an error log message that isn't whitelisted, then we fail. If a test assert doesn't pass, we fail. But there's not a good way to say, oh, this YAML fragment, like this test hasn't passed in the last week, or this test stopped passing or has failed every other run over the last month, or this combination of YAML fragments fail every time. We don't have any way of saying, oh, a particular combination of YAML fragments is now taking 4 times longer than it used to pass, and we don't have any way of tracking performance numbers. And from a pure functionality perspective, like the test functionally passed, that's okay, but from you want your storage system to behave predictably and to not get slower, that's not so great. So we need to either find or build some trend tracking software that we can integrate with Pulpedo and the wider teuthology frameworks, and start picking up on those things automatically. A minor problem which we've mostly fixed is that suites explode in size. They are a combinatorial explosion of every single YAML fragment, and every time we add a new feature or condition or configuration option that we want people to switch, the suite doubles. So obviously that's bad if that means it keeps taking longer to run. In addition, it means that it's harder for newer developers and third-party people to know which tests are the most important to analyze if there's a failure. It means that you're using up more compute resources that you might not have very many of. So we have a subset functionality that Sam wrote 3 years ago, I want to say, that uses all the YAML fragments, but not the total combinatorial explosion. And you can split it up into subsets of however many you want, and then iterate through those subsets like over time, rather than on every single run of the system. And so you can get it down from 124,000 jobs to 397. That's still a reasonable cross section of the tests, and that makes sure that every option gets turned on at least once. In addition to the subset, we also have filter scheduling, so you can do things like say, hey, I don't want to run anything on file store, or I only want to run the things on file store. When we have test failures, we can say, hey, I want to rerun this suite again, or I want to rerun all the jobs that failed in this previous run because I made a small change that I think fixed that, and I want to validate that before I put the whole PR through again. And so that's mostly under control. A bigger problem is that scheduling is very primitive. Like I said, it's beanstalkd, and jobs go in the order you put them in, and then you have like 50 processes racing to say, hey, is there a new job I can have? Oh, I got a new job, and then the process locks the number of nodes it needs, and then it runs the job. But if that means that if you have a 5-node job, it never ever runs because the process gets it and says, hey, can I lock 5 nodes? And the lock service is like, no, I only have 2 left. And we have a whole bunch of 2-node jobs, so they just keep taking them out from under the 5-node job. In addition, scheduled nightlies can be delayed for days because people keep on manually scheduling suites at a higher priority, and then a week later there's room, and so now we're running a full nightly RADOS test on a week-old SHA-1, and we'd really rather be running the current one. So we've come up with some workaround hacks, like basically all of our jobs run on the same number of nodes, mostly 2, which we've gotten accustomed to, but is also a problem. We have people who spend a lot of time monitoring the beanstalk queue and killing and rescheduling old nightlies as they age out. It would be great if we could update the existing scheduled test runner so that we lock the needed machines before the job gets off the queue, and that way stuff still comes off in order and gets what it needs without a big, huge change to the rest of the system. And it would be great to get a more robust scheduler. Also, I think it would be awesome if we could automatically adjust the number of nightly jobs based on the system load and do things like say, hey, I want to run like this job against master, but like pick the latest master when the job executes rather than when the job is scheduled. And we're coming down to the end here. So there are some changes coming to modernized teuthology that we've been discussing for a while and doing a little bit of work on. Kubernetes and Rook. Big change to the Ceph ecosystem, big change to how people deploy Ceph, big change that we want to test. And we're talking actively about how to do that. One thing that is in slow progress is actually running Kubernetes inside of the teuthology framework using Minikube or something to spray out a small Kubernetes cluster and run Rook inside of it, and implement what I'm calling deployer interfaces that can talk to that either are an implementation like the current existing ones for installing Ceph and running it, or one that uses Rook and Kubernetes in the back end, or one that uses Ceph Ansible or DeepC or whatever. But another thing that's being pushed and that people are working on is just writing Ceph tests in some kind of Kubernetes-friendly framework that exists. Sage is real big on Prow. There are several options. And the idea here would be that it would be quick and easy to get Ceph running inside of the system, and we can write tests around those integration points. The concern that I have around that is that we might misidentify what the integration points that we need to test are, and not correctly identify risky areas that need coverage. With that, and we might just end up re-implementing all the existing tests. And I mean, if we do that, then we now have all the tests re-implemented inside of a modern framework, and that's great, so we can just switch to it, but we're probably not ever going to reach that point if we do it incrementally without having some kind of portable system. Additionally, within the teuthology framework, the physical machines are first-class citizens. If you think back to the YAML fragment I showed you, it was machines with an IP, specific machines with an IP address, and we do things like package installation on those individual target nodes, or things like power cycling on those target nodes. And daemons like a Ceph OSD belong on that machine. But in Kubernetes, that's nonsense. You have pods, and those pods might be, you might know something about the scheduling of those pods, but you have to install the container image on that pod, not the container image to some machine. So we need to build out new interfaces for dealing with stuff like that. And that's the end of what I got. We have about 4 minutes left. If you've got any questions you want to go around, Brad is graciously volunteered to carry a microphone. So, bring it at me. Thanks very much. Any questions? Wow, no heckling either. You must have been super bored. Well, in that case, I'll be around all week. Have a great rest of the day at Cephalicon.